Okay, later you will know better. So for this part, to be why we need to have design rules, because we need to avoid some fabrication errors like this form. So if you have a misalignment like this, you're going to see that you want to place maybe polysilicon down here, and then you want to overlap with a diffusion layer. So when you misalign, if you do have errors, then this is the misalignment. And then a dust particle also occurs, where maybe you have a transistor like down here, but when you have dust in the clean room, then that particle will affect. Let's say there is a dust here, then it will shorten the path of the gate here with the end diffusion. So it will shorten this. We do not want this. So we want to avoid this. We do not want to have a fabrication errors like this. And then process parameters. For example, the lateral diffusion. You need to observe the process parameters. How much is the minimum diffusion layers, and so on. So it will give you some errors there. So please follow exactly, and yeah, accordingly. And this one, the last one, it's the rough surface. If you remember, we have every layer has to be planar, right? So you every time we do the fabrication of one layers, we need to polish the surface of these layers. So maybe like polishing using the chemical mechanical polishing. So if let's say we have some roughness here, if you polish this, it will give you a flat surface. But if you are not polishing this one correctly, when you layer it with another layers, then you will actually bump another layers like this. So you do not want this. It will affect the process. So this is one of the contribution factor of errors in fabrication, which is the rough surface. Okay. So for minimum dimension, or maybe the width here, for each object, each layer to maintain that object after fabrication. So let's say we have like these two metals, metal 1, and this is also metal 1, but you want to place next to each other. So if you want to put the layout, you should at least observe the 0.3 micron of the width here. Okay, and this width also 0.3 at the minimum width. And next to each other, you should observe the 0.3 micron, so that you do not want to shorten both metals if it is too near. Okay, you do not want to short this path. And then maybe also there's another problem occurs. Like maybe there will be electron migration between layers. It will jumps from one to another. And then maybe also you're going to have experience a crosstalk. Let's say you send a very high frequency to one metal, and then it will interfere the second layer, the second metal on just next to it. So this one becomes a victims. Because when you supply a very high frequency on one metal, it will interfere this second metal. So you do not want this. You need to observe the minimum space between objects on the layers. So just to avoid the shorted path or crosstalk.